So I'm going to go through the respiratory lab worksheet, and for this first part here, you'll want to make sure you're looking at the wall versus the mucosa. So for the first one, the bronchial wall, the walls of the bronchus, remember this is still cartilage. So here we're going to see hyaline cartilage. The bronchiolar wall, remember the bronchioles, what causes them to constrict and dilate? That's the smooth muscle, right? Alveolar duct, this is going to be the same as the alveolus. What do you remember about that? Remember that's going to be our simple squamous tissue for both of those, so we'll just go ahead and fill this one in down here too. The tracheal mucosa, so the lining of the inside of the trachea, this is our pseudostratified columnar, right? And what else is on there? Whoops, remember we have cilia as well. The mucosa of the bronchus, what's that? Remember that's going to be our simple columnar. Some of it might be pseudostratified, but most of it's going to be simple columnar. The walls of the trachea, the outer walls, these are also going to be hyaline cartilage. And then the mucosa of the bronchiole is going to be that new one, that simple cuboidal. Of the ones on here that we didn't use, remember the stratified squamous we really don't see. Remember we saw this in the esophagus, but we don't really see that here in the respiratory system. Okay, so for the second part, you are drawing out a spirograph or spirogram template. And so it tells you what to do here. So you'll start your tracing at 3 liters, which means you'll start it right here. And you are drawing 2 tidal volumes, an inspiratory reserve volume, which is the IRV, 2 more tidal volumes, an expiratory reserve volume, let's see here, 2 more tidal volumes, and then the vital capacity will end with 2 tidal volumes. So the vital capacity is going to be, you know, another one of your parts on the graph here. And then you'll end with 2 tidal volumes. So if I lay all that out, so we have our 2 tidal volumes, remember that are about 500 milliliters for a normal value. We have the inspiratory reserve volume in dark blue. Remember, inspiratory reserve volume is the maximum inhalation after a normal tidal volume, so it's after that there. So we're basically going from about 3,500 up to about 6,500 if we're looking at a 3,000 milliliter or 3 liter average value. Then we have 2 tidal volumes. Then our expiratory reserve volume, looking at about around 1,200 milliliters or 1.2 liters here. Remember, that's the purple. Remember, that's after the tidal volume expiration. 2 more tidal volumes, and then our vital capacity, remember that's everything except for the residual. So we have our normal tidal volume, inspiratory reserve volume, tidal volume ending, expiratory reserve volume, and then ending with 2 tidal volumes. So if we look at the bottom of the worksheet here with lung volumes and capacities, so first the maximum volume of air that can be expired after inspiring maximally, excuse me, I can't talk. And so when we look at these values, what are we looking at here? So there's a couple things to consider. So this would include our tidal volume, our inspiratory reserve volume, and also our expiratory reserve volume, and that's going to give us our vital capacity, or VC. So vital capacity on page 63 in your lab packet also goes through these values. The volume of air inspired or expired during normal quiet breathing. Remember, this is going to be our tidal volume. So tidal volume is there. The volume of air that can be expired in addition to a resting expiration, this is going to be our expiratory reserve volume, or ERV, expiratory reserve volume. And the volume of air that is always in the tracheobronchial tree, which can't be measured during spirometry, that's actually going to be our dead space. And then the volume of air that's usually within the tracheobronchial tree, which is available for gas exchange between inspiration. So we have two types of dead space. We have our anatomical dead space, and then the part that's actually available is the physiological dead space. The difference between these and other types of capacities is that this is what's in the tracheobronchial tree, whereas something like residual volume is looking at the amount that's in the lungs that's sort of not coming back out. Okay, so performing selected tests, compare the results to reference values. So since a lot of you didn't really get a chance to do this, remember that the normal ranges are here and you're going to want to know that. So this value looks at the amount of carbon monoxide. If we look at baseline spirometry versus bronchial challenge, remember the values for these are kind of what they mean. That's probably what you're going to want to remember. So we kind of looked at that on the first page. So what do these values mean? If you are given different values, can you calculate them using a spirometer reading? Bronchial challenge test, again, this would have been from actual numbers that you got. But remember that the forced vital capacity is the amount of air that basically can be expired after a huge inhalation and a huge exhalation. And that should be about 80% of what is predicted. What this is doing is measuring for those restrictive diseases. So things like polio and MS, where you're restricting the lung elasticity. The FEV1 is the amount of air that can be forcefully exhaled in the first second. So typically that's going to take 5 to 6 seconds. So in the first second, that should be about 70 to 85% of that FVC. This number will be reduced in individuals with obstructive pulmonary diseases like COPD, like asthma, etc. And then remember here, just kind of looking at these different values. So the minute respiratory rate, or the minute ventilation, remember you are taking your respiratory rate, so your respiratory rate times or multiplied by your tidal volume. And so what you end up with there, if your respiratory rate is breaths per minute, your tidal volume is the volume per breath, then you end up with basically the volume per minute, or the minute ventilation. And so then again, using appropriate data, and if you're asked for these, you would be given that appropriate data. The other thing I want to show you on Blackboard, if we go to our lab section, respiratory system, I do have some of those tracings of the spirometry worksheet or pictures here, and so you are welcome to look at those. And basically what you'll want to be able to do is identify with what each of these things are. So basically here we have, this looks a lot like the one that we did on your worksheet, right? So 2 tidal volumes, inspiratory reserve volume, 2 tidal volumes, expiratory reserve volume, and then we have that vital capacity here. And so when we're looking at all of those, you want to be able to know what they are and then be able to calculate things. So for example, what is this person's ERV, the vital capacity, the inspiratory capacity, when we are looking at those. Remember to look through your lab packet then at the different types of measurements. You'll want to know the ABG values and go from there.